Okay, welcome everyone to CyberGIS'14. Welcome to Esri. Welcome to Redlands. My name's Steve Cope. I'm the Esri representative on the NSF CyberGIS project, and I'll be sort of helping try to keep things running smooth this week while you're here. But thanks all for coming. First, I'd like to start by introducing Shaowen Wang, who is our conference chair, who's going to help start us off. Come on up.
Thanks much, Steve. Good morning. Wonderful. Welcome to CyberGIS'14. It's so delightful to have you all here. Hope your travel was smooth and pleasant. And if I could move this forward. How many of you have got my welcome message a few days ago? Super. We also have online streaming today. Steve just sent me a note. I'm sure Dawn will tweet that link, and we'll also send that link to some mailing lists. So this will be online streamed for the entire program. As you could see the website, we have two fantastic keynotes this morning, and it's a fully loaded 2 days program, and the third day morning will be squarely focusing on CyberGIS education. Well, why we are here? Primarily, this is an event put together by this particular NSF project, 5-year project. We have a fantastic team from 9 institutions leveraging tremendous partnerships with Esri. Here we are, and also USGS, the Center of Excellence for Geospatial Information Science, Dr. Lynn Esri is directing, and Oak Ridge National Lab, the Geographic Information Science and Technology Group, Budu Buhar is directing. So this is a tremendous community activity, and started 2012. The first conference, CyberGIS Space and Time, took place at Urbana-Champaign. How many of you were there? All right, we got newcomers. That's always positive. And there are so many people to thank for putting such a tremendous program together, starting with Steve running on the stage, behind the curtain, and also my colleague Anand Padambanam from the CyberGIS Center at UIUC, and Tim Nigers, who is in charge of the community engagement program in the CyberGIS project. And Esri colleagues down right, David DiBiase, I don't see David. Hey. But many others in the CyberGIS project team helped put this together. I'm so grateful. And of course, the sponsors, Esri primarily, JAG's generosity, NSF, the project sponsor, and the CyberGIS Center for Advanced Digital Spatial Studies and at UIUC. Well, a very quick introduction. I think you're all too excited. I'll cut this very short by starting introducing our formal program. I'm tremendously honored and very delighted to introduce the first keynote speaker of the morning, Jack Dangermond. As all of us know, he's the founder and president of Esri, really needs no introduction. And I cannot imagine any other person on this planet have made this much impact on the GIS industry and broadly geospatial research and education. And he has numerous honors, numerous honorary degrees. I think in the interest of time, we're not going to enumerate all of that. But just a little personal note to make this concrete, to me at least. This is almost a dozen years ago, so I was one of the beneficiaries Jack supported for me to attend GIS Science 2002 conference while I was a graduate student. So this makes you or me feel like this kind of impact is felt at personal level. With all that, let's thank Jack so much. for hosting this conference and for kicking off the program with his keynote. Jack, thanks.
Thank you. Thank you so much, Shaowen. Okay. Well, thank you very much for those nice remarks, and welcome to Redlands for all of you. I feel like you are my colleagues, and that I'm sort of part of you in many ways. Any of you could have done what I have done at Esri. I started in a lab very similar in nature to what you are doing now with CyberGIS and what happened at Santa Barbara in the 80s and 90s. It was the Harvard Lab for Computer Graphics and Spatial Analysis. And there we pioneered some of the first computer mapping. We didn't know what we were doing at the time, but I guess GIS, today we would call it GIS, work. And that was for me just thrilling. We were able to advance the method of computational geography, and Esri was born out of that, as were a lot of other initiatives, both in the academy and also in the private sector and government organizations. The topics that I want to cover today are two: my interpretation of CyberGIS, which is pretty much corollary, I think, with you, and also a bit about a concept we are calling GeoDesign, meaning the whole community, and see how these two things bounce back and forth. But before we do it, I'd like to again give my version of the purpose of this meeting, and it is, I think, first and foremost, just to be together. Today in the cyber world, we don't get together face to face so much and get to know each other and learn from each other and share actually what we're doing. And that's a sad thing, that we're not sharing as much in face-to-face. I like to call it spiritual sharing, although that's a little airy-fairy, but you know what I'm talking about? Yeah. And that's so valuable. So I always like to start off these meetings by having you meet one new person, a new person, not one of your old colleagues, but stand up, walk around, introduce yourself, tell them who you are, and listen to them for just a second. So could you do that for me now? This will require some walking, I realize. Okay, good. That's good. All right. Hi. Okay. Good. Perfect. That's good. That's very good. Thank you. That's perfect. That's good. All right. Yeah, cut it off now. Yeah. Good, thank you. Perfect. It's a good idea, isn't it, in a way? My sense is that you are special people. You might say self-selected. Maybe that's one way to look at it. I don't know how you got to this particular position in life. You sort of evolved, you sort of designed your way to this moment of expressing who you are and what you're doing. And design is part of it, and I want to talk about design. I believe that we do design our life, we design our future. We're, of course, at the effect of circumstances that affects us from DNA and other things, but also we consciously design what we do. We think it out. It's a theme that I want to cover and get you conscious of, is that we are the authors of our life, and you authoring, being here in these seats, to me is quite thrilling because it suggests that you're very special. You are not only technically alert, but you also have the intention of using geography and geospatial dimensions to actually work in your career. And being able to meet each other and build relationships, at least it's my experience that it's what makes things really exciting and work. You learn from your friends. You don't learn just out of books. You learn from real experiences. And so that's actually what I want to do, is talk about my real experiences with respect to where I see GIS, where it is today and where it's going. I'll start with this notion that GIS is changing how human beings understand their world, how they think, and also how they behave. These little words are all components which live in different organizations and different disciplines. People measure things, they have hypotheses, they predict things, they analyze things, in some professions they design things, they decide about. In one way you could look at this as a workflow from measurement to modeling to analytics to designing to deciding to acting. That's the way I sort of make it up. And at the heart of that is GIS, geospatial technologies. It's one of the powerful things in the sense that it's linking these various separate tasks together. And I see this in little projects that students do, and I see it in grand ways that people are approaching creating the future for the national park system, or creating the future of cities, or creating the future of utilities. They're all kind of doing this. In other words, it's this technology and your field, the science which you are advancing, is underpinning almost every kind of effort that humans are up to, from health, from education, for locating commercial activities, and so on. So I simply say applications provide the evidence that this is so, that this is the way it is. And I like to start off a meeting like this showing some of the applications that real users are doing. These are from the users conference this year. They're sort of combed, they're sorted out of literally tens of thousands of expressions that were sent here. Some users are monitoring environmental change, doing environmental assessments at the global level and micro level, as these examples suggest. Others are managing natural resources like forests or water or mining or extraction industries, mineral assessments, and the like. These examples show GIS used in urban planning and urban design, from neighborhoods to doing simple walkability assessments like in New York, zoning, planning efforts of all types. This touches on the theme of this conference of GeoDesign. And this is at lots of different scales, from the whole globe, like carbon sequestration, all the way down to particular buildings and how we manage spatial stuff in buildings, rooms, optimizing room usage, optimizing campus usage, and the like. It's being used now extensively in business. The Fortune 1000, one of our colleagues here recently looked at this. About 800 or 80% of the Fortune 1000 companies are using geography, your basic science, in locating or assessing their businesses in various types. And the human health dimension, with polio, now Ebola, malaria, epidemics, as well as long-term studies of human health and the environment, geography is an essential element. GIS is now common in preparing for and responding to natural disasters, floods, hurricanes, storm surge like in Sandy last year, and on things like social and ethnic violence, as we're seeing so often here in recent years. GIS is also providing us a foundation for advancing science by hooking up with citizen science, using crowdsourcing methods, assembling information from the informal collection sources. And this is changing how we do geography, how we do GIS, how we manage our organizations. If you look at all of these, you might ask the question, and I often do, why is your field, GIS, so compelling? And a kind of simple set of answers is, maps are really compelling to people. They communicate. People understand things quickly. The visual dimension is sometimes trivialized, but it's working on getting the graphics right is really important. And spatial analytics, modeling, being able to predict, this is becoming more powerful in the world of organizations wanting to have more, BI backgrounds, business intelligence or application intelligence. Spatial analytics is finding its own way, finally. People are beginning to say, wow, I see, you can really do something here. And then the technology, particularly in this CyberGIS space, is advancing. The web, the cloud, this is changing things. It's making GIS much more accessible. And in all of these cases, it's being driven by something. It's being driven by the need for better decision making. This is what certainly attracted me as a young landscape architect student, is how can I really make better decisions out of all this geographic data? And that's now catching on and becoming very appealing. And the communication aspect of it. And then there's just simply the fact that geography as a integrative science is pulling all of the ologies together and advancing the integration of different science domains. And for me, that's one of the big payoffs is all the ologies, archaeology, hydrology, climatology, sociology, and economics, of course. It's not an ology, but it certainly is in the fray of being integrated in a spatial plane. So I have borrowed a few slides from the keynote that we gave last summer at the users conference, and I'll weave them in. Some of you who went to that meeting will recognize them. But I simply say, if you look at this image and use your imagination a bit, I think you can begin to get where we are going, linking together all measurements, organizing them in a geospatial setting, having tools that allow us to integrate and exploit this information. I think GIS in this space becomes an instrument of evolution. Is it just the internet? Is that what will do it? Is it just computing? Is that what will do it? Those are pieces of it. But in a broader context, I think the whole CyberGIS space will become a foundation for the way that we evolve the future. And speaking about the future, it doesn't exactly look too good at the moment. Our world is facing really serious challenges with the confluence of exponentially growing population and the kind of human footprint that it creates on environmental change, climate change, down to the destruction of core nature and the ecology that it lives within. For me, geography plays an important role. It's probably more important at this moment in time than at any other time, providing two things. One is an organizing framework for content, all that we measure, but also a contextual setting so that we can begin to look at things with a contextual view. What does this mean? It isn't just the measurements, but what is all of this environmental change mean for not just the environment, but we can see it. I mean, the world is on fire, right? I read the newspaper this morning. Even in our own country, the world is on fire. I mean, in the Middle East, it's on fire. In Ukraine, it's on fire. Social tension, these are all sort of related. And so the role of geography and the role of the GIS professional, I think, is extremely important. It's why your work in this field, each of you as individuals, is so important for creating the future. CyberGIS promises to integrate geography into everything we do. I mean, GIS has done a very nice job so far, those examples that I showed. There's a couple million people that hit the keyboards every day around the planet that are making decisions, communicating things. Enormous footprint of impact already. But as we turn the dials up with what CyberGIS really promises to be, it will further impact how we see the world and also how we behave in the world. The technology itself, as many of you especially know, is evolving. Individual pieces like servers and desktops and apps are all getting connected to what I guess I would describe an interconnected platform. One might call this CyberGIS. I conveniently called it WebGIS. It's not desktop GIS, although it integrates desktop into it. It's not server GIS, although it connects services from distributed servers into it. It's about shared community content, so we're leveraging each other's content in an open web environment. It's about bringing together all the data and the technology and the bits that create a framework for what? For what purpose? For addressing the very same complex issues that are driving us crazy. This isn't for idle stuff of just a science lab. This, from my view, and I am biased on this, is tilted towards the application of scientific knowledge to the creation of the future. So this WebGIS or CyberGIS basically brings it all together from my perspective. It leverages the advancing technologies of measurement, the neon kind of world. It leverages the advances of Moore's law in computing. It advances our improvements in networks. It brings it all together. WebGIS integrates all types of information. The traditional digital maps or computational geography, the models and analytics, imagery in near real time coming in from drones and other sources, in situ information, the whole neon notion of measurement instruments everywhere. Sorry about this. Social media, the notion of tweets geospatially referenced, or Facebook or the like. Increasingly enterprise data, these Fortune 1000 companies are spatializing their information, and they're expressing them as web services and web maps. They are serverizing their information. And the whole big data supercomputing environment that some of you live in is being able to be expressed as services in a new medium of REST that allows us to not only look at this information, but also merge it and analyze it in unison. And these data sets, literally millions of them now, expressed as services on the web, are being organized in portals for easy to use access and search. Both internally inside of organizations this is happening. People like in Walmart, for example, or in the Department of Interior or an EPA or in the city of Boston or in the city of Philadelphia or in the city of Minneapolis, not only are they organizing their information as services and web maps internally for easy, agile use, but also in a greater context on the open web as individual services that were not necessarily designed to come together prior. And the app revolution is being able to ingest these services. Young developers building apps out of services are making this stuff come alive for the whole consumer and citizen world. This WebGIS is changing how many of the users, our customers, GIS professionals work. It's improving how the individual shares and organizes their knowledge, enriching their own work, in other words, reading in services from other organizations. But it's also supporting a greater context of sharing and collaboration. In my car driving in this morning, I was listening to the NPR talk about sharing your car. You know, there's a new company that lets you share, like a rental car, your car. And it's just about a break-even proposition. You can share your car for rent instead of Hertz. You know, you can rent one of these cars. I forget the name of the company. But one of the people that were being interviewed were saying, I don't really care about the money part. I just like the idea that my car is being shared with other people, used up. I thought, that's very peculiar. Except that it's not. We're living in a culture where people are hunting for meaning and sharing their work in such a way that other people can actually use it beyond their own little stovepipe of work becomes very important. So I'll simply say it again. This WebGIS, CyberGIS environment is not only changing how GIS professionals do their own work, but it's putting them into a context of a greater cause or a greater frame. This WebGIS pattern is different than the last generation of GIS technology that we've lived through, which was largely organized around databases. We would organize semantically a data model and multiple people could share it. Great. And that doesn't go away with this, but the new notion is being able to dynamically bring in distributed services and be able to combine them in a more agile and open environment. And that means not simply look at the map, but also visually overlay this map from you and this map from you and build a so-called mashup. And not simply a mashup, but also particularly interesting to many of you, moving that into the analytic frame, being able to do dynamic analysis of these measurements and those measurements all at the same time. That has the effect of breaking down the stovepipes of individual disciplines, but also the stovepipes of individual departments. And each of you have your own experiential frame for this. It's actually bringing it together like we only could imagine 45 years ago. This is just sort of like unbelievable. I no longer have to put up with the bureaucratic nonsense of barriers or reasons why I can't share and integrate this discipline with that discipline. No, I'm freed and liberated in the extent that I can have open access and integration to support new collaborative approaches. One of those approaches is GeoDesign. GeoDesign is a formal set of methodologies and tools that leverage bringing the GIS data together with the design and decision-making process in a collaborative and open environment. Particularly with CyberGIS, this is powerful, so that I can generate alternative plans quickly and evaluate the consequences of the plans by bringing multiple sets of information into my design frame. It's very powerful. And many of you are thinking, well, Jack is a landscape architect. That's what he's talking about is the design profession, urban design or urban planning. And there's no question that GeoDesign is a valuable methodology for that space. But I'll simply say that this is way beyond the design field. Farmers, do geodesign. Foresters do geodesign. People who do conservation planning do geodesign. How many of you here are actually designers? I'd like to ask this question. There's 1, 2, 3, 4, 5, 6, 7. Don, you're a scientist. What are you talking about, a designer? You ever noticed how Dawn puts her little act together? Looks really cute, beautiful. I love you because you always are conscious of how you look. And of course, the rest of you never do that. I mean, you know, you design your little outfit. You design your bedroom or your house, or you design where you live. You are all conscious designers, almost in every field. You consciously think about a way that you want it to be, and you put it together. You design your families. You design your careers. And some of this is sort of evolving along. You don't always have it all together in the beginning, but some people do. So let me just say that geodesign doesn't belong to the traditional design field. And that'll set it in motion. You know, Walmart is doing geodesign. Starbucks actually admits doing geodesign. They pick their sites and you know, like that. Military does geodesign. They lay out a design for attack. It's not necessarily what most of us are thinking about, but it makes you think that, wow, geodesign is a generic kind of field, and it's independent of any particular discipline and worth paying attention to. Creating a better future requires the integration of science and design. That's my assertion to you. And that will require everyone envisioning what's possible, providing leadership in this, particularly you, because you're grounded in some of what is important, understanding and embracing this new CyberGIS world, and also the notion of geodesign. I think that's what's really important to discuss about in this particular meeting. Now, I might be running out of time. Steve, how am I doing on time? I'm okay? I have 20 minutes. Okay, then I will also share with you what we are doing here. Our work at Esri is about building enabling tools, and we do that every year. We release some new software, some new tools, and it borrows very heavily from fundamental research that many of you are doing. I think our history has been co-evolving with the academic space all the way back to the days of the Harvard lab and through different iterations in different places. So I do appreciate the partnership with the Academy, and for many reasons I just want to say thank you and acknowledge you for being here, continuing this evolution and partnership. We do this largely through a product known as ArcGIS. Many of you are users, some of you are not. It is a technology stack. People used to buy desktops independent of ArcGIS, and we do have several million users who use our desktop product. People will buy servers independent of the ArcGIS world, and we have several 100,000 of these servers that are serving geographic information. But the frame that I want to present to you today is not simply those individual products. It is of a system that borrows on some of the thinking that you have been doing with CyberGIS. It is a complete integrated system that lives partially in the web and partially on premises that allows GIS to be looked at as services. These services are organized in a web portal and accessed by different kinds of apps. Some of these are lightweight apps and devices, and some of them are thick desktop apps. And all of this system, interestingly enough, can now be accessed in the cloud as cloud services. And it also can be totally implemented on premises. We've been extending the ArcGIS data model. In the 80s and in the 90s, our focus around geographic data was the file coverages and shapefiles. In the mid-90s to the late 90s, we developed something called the GeoDatabase, which was about putting geographic data into a relational database so we could scale it out inside of an organization. And that worked quite well, being able to have multi-user access. In the last couple of years, we've been working on something called the GeoInformation Model. It's just a name, but it basically takes files and data expressed as services or web services and transforms them into layers, that's a technical term, and web maps. What this web map focus is about is extending the geographic data model to include information products. The information products are expressed as web maps. So you might think of the web map as actually being in the data model of the domain. And while some of you will think of web maps in different ways, oh yeah, it's just a web map, it's just a Google map. No, a web map in this case is not that. And I'll attempt to define it further as we go along. It is a new, you might call it data type if we were living in the 90s. It's not a data type, it's a web map. It's a web expression of geographic information that can be persisted and is always available. And it is this transformation that moves from data or databases that really has made a huge change. These web maps can actually be looked at on any device, just like email. They're able, I can email you a web map, I can embed a web map, and as the data changes, the web map changes. They are an information product. And that has been the magic that allows us to make, that has been the magic that allows us to make a couple 100 million web maps a day in ArcGIS Online, for example. We couldn't do that at a scalable level if we were still stuck in the data file or the database. It's part of the scalability issue that CyberGIS enables. Given that background of the architecture and the information model, let me talk to you about some of the basic research themes that we're working on. One of them is in spatial analytics. This is both in the desktop and also in the web. We're inventing, and some of you saw yesterday, new space-time spatial analysis. Is Luke Anslin here? I didn't see him, but he's going to be here, I guess, maybe tomorrow. But yeah, Serge is here. With Lauren Bennett and others. We've been working on integration of real-time and multidimensional data with flow visualization, for example, into the desktop, but also in the online or cloud web environment, taking tools that were invented in the desktop or in the server environment and putting them as analytic tools that one could access dynamically. An example of this is a database of the entire United States. It's modeled with a suitability model or a predictive model of fire. The red areas are very high fire risk. I'm just drawing here a quick demo of where a fire has broken out, and it's reaching down underneath this layer into other layers and showing this is federal lands or county lands, so we know who to respond to on the fire. Also, we know what kind of people are living there, their ages, whether they are disabled or not, whether they're non-English speaking or not. It's kind of a very simple web map, which is a web analytics. It's a raster set of functions running in the web that supports an information product that is dynamic. So I'm tying a couple of data points here together. We're putting a lot of emphasis on real-time GIS. This was just an idea back in the 80s. Now it is coming alive with, in this case, technology we call Geo Event technology. This allows us to read in many sensors at the same time and do inline geographic analysis or things like geo triggers or geofencing or geo proximity analytics, dealing with tens of thousands of events a second. So you look at all the bad guys in the world and are they getting close to the good guys in the world? That kind of thing. Or all the ships in the world, like this example in the Arctic, coming from AIS tracks, and are they encountering or close to icebergs, or are they getting close to, or FedEx is using this, for example, to move hearts around, and they want to get, when the vehicle's getting close to a hospital, they want to send a geo alert to the hospital, so they run out the gurneys to get this thing happening. So real-time GIS has just huge implications for our field, particularly in the cyber world. A third area is in 3D, enabling web-based 3D visualization without plugins. This is a big area. Also, rules-based expression of 3D models. GeoDesign, something I've already introduced and talked about. Our work here is in something called the Geo Planner. I think they're going to demonstrate this afternoon, where you can sketch very quickly on a suitability map and get feedback and pick one alternative versus another alternative based on that kind of guidance. And we're also doing the same thing with City Engine in the urban design setting with 3D realities. These pieces of research this year deal with advancing the methods for dynamic image processing. Particularly this year, our emphasis has been to read in and being able to dynamically process very large amounts of scientific formats like NetCDF or GRIB, here coming from the GEOS family of satellites to support, let's just call it near real-time image processing of various types. Part of this effort has been to stand up all of the Landsat services for the entire world, and each night we refresh these and make the sort of multispectral data available to the entire world. Content has been one of the very large efforts that we've been working on, and this was an effort to take many different best available data sources from national agencies, both here in the US and abroad, and organize them into a real-time environment. ArcGIS Online now has about 2 million data sets in it. It's really quite extraordinary, and a few 100 million maps are made a day from this data set. This year we organized, I'll just organize this, what we call a living atlas, which basically involves 1,500 highly usable data sets, and make them available to our users. Things like imagery data sets from different image providers, data sets on demographics like 7,000 variables for the United States, income, age, obesity, all sorts of interesting things. Landscape information, soils, geology, vegetation, slope, elevation, as services. These are Earth observation satellites that are near real-time observational data like MODIS. We have a lot of data invested in urban systems, both in 2D and 3D. Things like real-time traffic or just traffic proximity. We've also spent some time building a collection of all the administrative boundaries for the world, cities, counties, and also we put a lot into historical maps. These are both the National Geographic's collections of historical maps. This one, in a partnership with USGS, is about historical topo maps. This is Los Angeles. I'm just simply zooming in here to Dodger Stadium. Dodgers, are #1 in the league right now. But anyway, this is a existing community map. This is historical 1895, what Dodger Stadium used to look like, and I can simply look at them back and forth. I can look at the 1953 data set. You can see this was before Chavez Ravine, the stadium was built, and I can compare and see that the survey is much better than it was in 1895 of information. This is quite extraordinary information and very valuable in some settings, because I can take something like the way it is today, grade it off a ball stadium, and see the way it used to be. We did the same thing with NAPE imagery. This is in the United States. This is all the multispectral high-resolution data collected by USDA and USGS. And I can pan and zoom on this data dynamically. This is, again, multispectral data, so I can manipulate this data. For example, look at it from a color infrared perspective, or look at things like NDVI or other simple classification tools dynamically across the entire US. This is the meaning of CyberGIS, is that we wire up real-time this kind of information and we make it available to people. So we're placing a lot of our research dollars into just organizing and making GIS data GIS ready, not simply collections, and organizing it in portals. To leverage all of that information, we've been inventing something called Geo Enrichment. Geo Enrichment is kind of an old idea and a new idea. Geo Enrichment says I can take all of these layers and in a user's data, like a spreadsheet of places like where people live or something, and I can use an online service to associate these points to all these different layers and create an extended spreadsheet. You get the idea? It's kind of like point and polygon in a way, but it's all set up in the cyber environment where I'm just taking my data and associating it with this dynamic thousands of data sets that are in the sky and being able to then do my spreadsheet analysis or do my local GIS with it. Apps are, as I mentioned, changing the way GIS really works. Free apps that live on any device that do things like data collection or do dashboards or exploration of data. This apps world is really intriguing, and there are some core GIS apps that we've been building here that are simply included as part of server and online. But again, one of the big popular things at the user conference this year was something called the Web App Builder, which is a cross-platform framework for building web apps very quickly. This is using HTML5 and JavaScript. It basically starts with a builder and has about 30 widgets that I can, as a non-programmer, I can build an app in about 30 minutes. Even Jack could do that. And then have a ready-to-use app that ran on anything, on my iPhone or on my Android device or like that. So this is going to change things, actually, with the services backbone and the ability for anybody in organizations to build quick apps, sophisticated apps, or very simple apps. It's going to open up the power of geographic knowledge. We've also built an app called the Open Data app, which is a notion where an organization can basically open up all of their databases and shove their information out as services so that it serves geospatial data as any format. Like a shapefile can be transformed into a KML file, or a geodatabase can be seen as a feature service, etc., so that people don't have to wrestle around with it. It's part of the cyber infrastructure. And interoperability continues to be an important part of GIS, both supporting standards but also industry formats, both technical industry formats but also domain things like One Geology, so that we have scientific interoperability within our field. Do I have 3 more minutes, Steve? Okay. 5? He's a tough guy, really. Where does all this technology stuff go? It goes into, at Esri, it goes into our engineering of a product. And I'll share this not because I'm trying to promote this stuff, but simply what we do, because in your domains, in each of your areas, ultimately it is expressing stuff in a form that other people can use, whether it's your research or product areas where it really hits the road. And we now no longer think, as I mentioned already, of online or servers or desktops. We think of it as a single system. Software and services is kind of the concept that dominates our lingo around here. So building a single platform supports desktop professionals, but that same platform supports knowledge workers and executives across an enterprise. This is a new chapter for GIS. I mean, there has been point solutions across the enterprise and mapping and so on. This is trying to bring it all together. And then use exactly the same platform, open up the hood, open source major pieces of it so that developers can use rich APIs and the content that I've been describing to actually build apps quickly. The online is a big piece. This is the cloud expression of ArcGIS Online. It provides mapping and analytics and content as map services. And our work here has been very much in improving the user experience and adding a lot of what you guys might think of as administrative work in the back office, certification for FSMA or Safe Harbor, so that people are okay with putting their data there and they know it's secure and it's not going to be some fiasco of stealing things. And also the ability to define custom roles for using this, and then being able to manage users with how much computer usage they have, so-called credits, and then being able to make new self-service sorts of mapping and analytics has been our research here. Closely associated with online is server. It's this little baby here, which also people are demanding a lot of security around these days. Naturally, you'd think that. We've also taken the ArcGIS Online experience, the whole front-end experience of it, the organization of web maps, and we've made it part of the server product. In other words, this is the way server looks today. It's a server of services that programmers can access. At 10.3, which is the release I'm talking about, the whole front-end experience looks different. I can help myself find services, discover them, mash them up, integrate them with other sorts of applications, including the desktop. Is this interesting to you? Or, okay. The last main technology is the desktop. We basically have changed how we think about the desktop. Now we think of it as part of the cloud, or we think of the cloud services as part of the desktop. It basically is one, you buy one, the other one comes along with it. That means you can author easily data and create services easily, like a right click and you make a web map. That means a little desktop user can create services with unlimited mapping just within their desktop. It's kind of like a server and desktop kind of come together. So the distinctions between the various types of technology are disappearing, and we're seeing that it becomes a platform, is the way, at least from the commercial side, we're seeing it as a platform, not individual pieces of technology. And part of that platform strategy has been to lift up the hood of the technology and make available significant pieces of it as open source, and then document rich APIs and runtimes to be able to make that more available. Some of you will find this intriguing for your work. So let me close with this. We keep working this. We have about 700 people in our dev area, and we keep releasing our work each year in releases, and also continuously advancing it and online. This next year, we are working on more real-time, massive 3D. Here we're talking about 3D for the whole planet. Native big data support, more advanced navigation, crowdsourcing, and others. These are all areas where we're wide open and interested in collaborating with you in various research areas. Last night I was thinking about what are some of the challenges that our users are facing when they talk about this WebGIS or CyberGIS, particularly at the research level. One of them is being able to archive historical web maps. If we buy into the premise that web maps are changing all the time because of transactions or ongoing measurement, what happens to the way it used to look? And to sort of make this very clear, you might think of some of you might know who General Clapper is. He's the head of the National Security Organization in Washington. That's CIA, DIA, NSA. Every morning he drives from Bolling Air Force Base down to the president's office and he gives them the daily brief. See where this is going. So suppose he has web maps now, and that's what they are doing. And he's driving down and there's new bombs that go off in Syria or Afghanistan or wherever it is. And the brief changes. Or somebody wants to go back and say, what did it look like a few hours ago, or a few days ago, or 2 years ago? That's an example, but it's certainly by no means the example. We have the same problem in forestry, it's the same thing in water, same thing in storms, same thing in litigation with insurance companies. How do we archive historical web map views of multi-sourced distributed information sets? How do we resolve map services reliability issues in organizations? That's another issue that shows up on this distributed cyber world. How do we express metadata of compound services, the so-called mashup map? How do we take this complex metadata and express it in a way that's actually easy? Is it just the long list of all the REST services that are connected? And then how do we deal with error and the issues of error around that? Very interesting research topics. Spatial analysis of distributed data. This is a technical issue. We have 2 data sets. We know that we need to do intersects of the data from a distributed environment. Do we have to pull the data out, bring them to a central supercomputer, and then do the number crunching? Or is there ways to dynamically cruise through the data row by row if we're working with raster data, or geography by geography, crunching vector tiles, that sort of thing? These are interesting issues. And then integrating CyberGIS into design workflows. This is, again, more or less selfish on my part, but I think I really like this notion of GeoDesign. So I'll leave you with that. I covered a lot of areas. The welcome. Welcome to Redlands, by the way. It's going to get cooler, that's what they say. I covered the general concept of what's happening with what I like to call WebGIS and what is commonly better called perhaps CyberGIS. What is the big vision of that? Why is it important? What in our little way here we're working on in terms of advancing different tools that are one expression of your research, and then left you with some challenges of areas that we just don't know how to figure this out, sort of thing. And I'd appreciate your collaboration and support. So thank you very much.
So questions for Jack?
Thank God.
You wowed the people, obviously.
No, there.
Yes, Tim.
Oh, okay.
So,
Sure.
10.3,
Yes.
2:15, is that the user conferencing? 10.15?
10.3 is going to be November. Yeah, it's already in beta. A lot of the things I did not cover, which is the desktop, for example, that's going to be transformational. It's a whole new user experience. 64-bit, very fast sorts of things. And that goes out to a few million people in November. It's going to be shocking because historically to build web maps has been hard. In 10.3, the building of the web maps and turning them into web services like a single click. That'll serverize geospatial information, or let's call it server-enable geospatial data. So every desktop user, it's important that they have a connection to the cloud because they'll be able to serve out everything. Once they can serve it out, it automatically gets registered. Then people can mash it up. They can create new information products, and it'll just sort of exponentially grow. So, yeah. Long answer to your question. November or December, I'm not sure. Might be December.
Stay tuned.
Yeah,
I think
stay
that's the
tuned.
answer. Maybe time for another question?
Yeah.
Hi.
Well, for the massive 3D service, is that based on the satellite imagery or?
No, 3D services are a fundamental part of the server. So we're supporting the notion of 3D, like building services or 3D. Believe it or not, 3D has not been serverized in the full, in all aspects, like 3D feature services. I mean, we've been able to easily send out 2D feature services or 2D map cache services or 2D imagery services. But the notion of being able, for example, to have, let's say that we took all the cities of the world and each city stood up a 3D building service of the urban footprint. And then I, as a user, had a little globe and I read in the 3D services from all of them. So I turned the globe and 3D services would be coming in very, very fast. So that's one example of an application for pulling that together. And again, it's not just visualization. That's maybe what I wanted to say, is it's in the 3D service expression, it's the ability to do analytics like view shed or shadow analysis or obstruction analysis on the 3D things that are actually being served.
So it has some of the functionality of like a Google Earth.
Well, Google is principally focused on visualization, and that's pretty actually easy to do. They use a voxel kind of model. What we're talking about is actually 3D feature services, so you can actually do geometric analysis on the features in real time.
Well, let's.
Yes, sure, David.
Will geoprocessing tools be open data be part of the next release?
Open data is already released. There's been over 1,000 implementations of it. And does that answer your question? That Apple?
I meant specifically, I was in a workshop on geoprocessing tools developed for Hadoop.
Yes. Oh,
And these tools do exist.
right.
But the question is, will they be part of the next release?
Okay, so right now we have open sourced the Hadoop geoprocessing tools, so anyone can use them. At 11, which is next year, we will be building some kind of technology right into the server that leverages big data environments. We're not exactly sure the extent of that. It's a development project at this point. But we're genuinely interested about how to have reach back from this web map, web services environment all the way into deep analytic processing environments that big data environments and also supercomputing environments can provide. So we have both internal, quite a large team of internal people working on that, but also we have a number of relations with different vendors like IBM, with their Netezza, and SAP with their HANA hardware environment, as well as the classic Hadoop environment. David?
Yeah, as you talked about one of the research challenges is about workflows, integrating what's going on here. Maybe at the GeoDesign conference with existing workflows in design. I wonder if there's some talk about trying to create apps that really do reach beyond these traditional GIS settings.
Right.
Whether they appear in traditional GIS or traditional design tools, like a CAD tool or
Yeah. Two quick comments on that, then we better stop because I want to listen to Amy. One is I have 3 comments. First, the Geo Planner. Have you been working with the Geo Planner? The Geo Planner is available to all, I think it's available to all academic site
And it has a
licenses.
presentation today, later.
And it has so that is a real workflow that defines Carl Steinitz's traditional 6-step method inside of a real product. And it ships, it's a CyberGIS application. It's all on the web. It ships with 35 different landscape layers for the entire United States. So that's a real application. The second is in the desktop at 10.3, there is a workflow engine, a task engine, that allows you to actually define workflow sequences. And if you define them, David, you can share them, email them to somebody else. So there's step 1, step 2, step 3. It's kind of a task engine. I'll just stop there. There's a few other efforts in the city engine, urban design space that you'll see at the January meeting in GeoDesign. So
Well,
thank you again.
hate to cut you short.
Thank you very much for this.
Thank
And
you so much. Let's
Thank
thank
you.
Kat again.
Thank you, by the way.